All right, so in this video, we're going to look at finding the slope of a tangent to a curve. And this formula here, M tan, means the slope of a tangent, which is equal to the limit as h goes to 0 of f of x plus h minus f of x, all divided by h. This limit is defined as the derivative of f of x at h. Now we're going to take a look at an example. Very simple example, the easiest one I can think of to have a look at right now is our function is f of x equals x squared. And we are going to find an expression for determining the slope of a tangent to the curve, because on this curve, the slope of the tangent changes depending on what the x value is. And so we're going to find a general expression for the slope of a tangent by evaluating the limit, or actually computing the limit as h goes to 0 of this function. So let's take a look at how that works out. The limit as h goes to 0. Now, for the numerator, f of x plus h, we need to find f of x plus h for this. So that actually is x plus h squared, because everywhere we see x in the function, we should sub in x plus h. And we want to subtract the original f of x, which is x squared, and divide the whole thing by h. Now let's work this out. We need to find a limit as h goes to 0. X plus h squared. Well, that is x squared plus xh plus xh plus h squared minus x squared all over h. Okay, if you wondered how I got that x plus h squared, we could work on that over here. X plus h times x plus h. We first do x times x squared. X times h is xh. H times x is xh. And h times h is h squared. Okay, so these are actually our 2xh. Right? All right, so let's rewrite that so it's not quite so messy. The limit as h goes to 0 of x squared plus 2xh plus h squared minus x squared all over h. Now, simplify that. We have the limit as h goes to 0. X squared, subtract x squared. Those two things cancel each other out. So we are left with 2xh plus h squared, still all over h. Now, I think it's helpful to put each of these terms in the numerator over h individually and do the canceling of h. So I'll show you what I mean by that. The limit as h goes to 0. I'm going to write 2xh over h plus h squared over h. Now we can do canceling of our h. That cancels that. And one of those cancels that. So let's go up over here. The limit as h goes to 0 of the first term is 2x, and the second term is just an h in the numerator over 1, so plus h. And now we can find the limit of this function here. The limit as h goes to 0, well, as this value approaches 0, that term will approach 0, and so this is just equal to 2x. Now, if I wanted to evaluate the limit at a specific point on this curve, I could say, actually we should write an expression down here first before we finish. M tan is equal to 2x. This is an expression for the slope of the tangent to this curve. What is the slope of the tangent at x equals 3? What is the slope of the tangent at x equals 3? Well, we find that by figuring out m tan at x equals 3 is equal to 2 times 3, subbing in a 3 for our x, and that equals 6. So at x equals 3, the slope of the tangent equals 6. And there's an example for you for finding the slope of a tangent to a curve. I hope that was helpful.